is n cubed 3 to the power n plus 1 over 4 to the power n, and s of n plus 1 is equal to n plus 1 cubed 3 to the power n plus 2 over 4 to the power n plus 1. So you have these bits. We are going to use them with the ratio test to find out what's going on. All right, so the limit as n approaches infinity of all right, so what you're going to do here is that will be the absolute value of n plus 1 cubed 3 to the power n plus 2 over 4 to the power n plus 1 divide by n cubed 3 to the power n plus 1 over 4 to the power n. This will be the limit as n approaches infinity of the absolute value of now we change from, so the first bit will remain the same. This will be n plus 1 cubed 3 to the power n plus 2 over 4 to the power n plus 1 multiplied by 4 to the power n over so 4 to the power n over n cubed 3 to the power n plus 1. All right. So the limit as n approaches infinity of the absolute value of now I'm going to rearrange things here like what I did previously. So n plus 1 cubed over n cubed multiplied by 3 to the power n plus 2 over 3 to the power n plus 1 multiplied by 4 to the power n over 4 to the power n plus 1, which will give us so this actually this bit will give us 3. I don't want really to cancel, that's not right. This will give us 3 and this bit will give us a quarter. So what we'll end up with is 3 over 4 multiplied by n plus 1 cubed over n cubed. All right. So we can carry on and say that this bit will be equal to 3 over 4 limit as n approaches infinity of n plus 1 cubed over n cubed, which will be equal to 3/4 by LHR. All right, L'Hopital's. That is, so the fact that our limit is less than 1, it means that our series converges by ratio test. So therefore our series okay, so it converges by ratio test. Next question. Now again, we are required to determine the convergence or divergence of this series. Now, S sub n is n to power n over n factorial, and S sub n plus 1 will be equal to n plus 1 to power n plus 1 over n plus 1 factorial. So we're going to use these bits and the ratio test to find out what's going on. So the limit as n approaches infinity of n plus 1 for n plus 1 over n plus 1 factorial divide by n to power n over n factorial. Well, this will simplify to the limit as n approaches infinity of n plus 1 to power n plus 1 over n plus 1 factorial multiplied by n factorial over n to power n. This will give us limit as n approaches infinity of I'm just going to rearrange these things, so we can bring the n to power n's on one side, the factorials on the other side. So n plus 1 to power n to power n over n to power n multiplied by n factorial over n plus 1 factorial, which will give us now this is n plus 1. Okay. Okay. Anyway, this will give us n plus 1 to power n plus 1 over n to power n multiplied by n factorial over n plus 1 multiplied by n factorial. That cancels out, and we can simplify this because this is n plus 1 to power 1. We can simplify that with that as well. So what we end up with is the limit as n approaches infinity of the absolute value of n plus 1 to power n over n to power n, which will give us something like limit as n approaches infinity of now this is just same as n plus 1 over n to power n, n plus 1 over n to power n, which will be equal to limit as n approaches infinity of we can write this as n over n plus 1 over n to power n, which will be equal to the limit as n approaches infinity of 1 plus 1 over n to power n. And you remember that this limit is equals to, this is the exponential limit. Which is equals to e. So this will be equal to e. Now, e is greater than 1, which means we can go ahead and say, hence, this series diverges by ratio test. Okay, it diverges by ratio test because the limit of absolute value of S sub n plus 1 over S sub n is greater than 1. All right. Last example. For what values of x will the series converge? For what values of x will this series converge? So what we need to do first of all is to find out what we need to do. What's the plan of action? We know that by ratio test, a series converges if the limit of S sub n plus 1 of S sub n is less than 1 as n approaches infinity. So the series will converge if the limit